Hello everyone, I am Narsimlo from G338 Group. Our project is GenAI Med-Diagnosis and Drug Design Tools. With the help of our mentor, Devika ma'am, we complete this project. This is a project AI-driven platform revolutionizing lung disease diagnosis and drug discovery. Our mission is to enhance the patient's care by the integrating advanced machine learning with medical imaging and molecular modeling, accelerating the development of effective treatments. This web application leverages the generative AI and machine learning to enhance the lung discovery, diagnosis, and accelerating the drug discovery. It integrates the medical imaging and parasitmical researchers into a unfilled platform to faster, more accurate outcomes. Technologies we used are Munstack, GenAI, ML, and webhooks. For deployment, we use AWS. The tools we design and features of this project are lung tumor segmentation using Unitar, an AI-driven segmentation of CT images for early and precise lung tumor detection, and also smile masking identification identifies chemical structures using the advanced GenAI models. Then 3D image 3D medical image viewer, interactive viewer for exploring the lung CT images, detailed clinical analysis, and ligand identification for Alzheimer using VIT applies the visual transform for the predicting ligands targeting Alzheimer's. Drug molecular generation using reinforcement learning utilizes the reinforcement learning to design novel drug-like molecules. And we done protein to smile converter and protein 3D structure visualization and auto docking. Auto docking means uh, protein ligand docking simulates the axis binding affinities. Lung tumor segmentation. For this, we use the Unitar model, one of the best segmentation model, to achieve highly accurate segmentation and classification of lung tumor in CT images using Unitar transformer. A transformer-based architecture optimized for the 3D medical image analysis. We use the dataset from the Kaggle called lung cancer segmentation. uh, and also this unit of architecture is U-shaped. One side has a downsampling and another side have upsampling. At the end, we have the convolution layers to combine all, and also a future for future extraction. At the end, we have the fully connected layer for the classification. This is a model summary of our model, and accuracy we got for the around 3000 images. We got 99.8 accuracy. This is a input image. This is like output image. We segment that tumor here is appears. We train our model by using a technique called federated learning. Federated learning is used to train machine learning models collaboratively across decentralized devices and servers, keeping the data localized and ensuring the privacy and reducing the need for centralizing data and storage. For less GPUs and also more number of data, we use this technique. There is client 1 and client 2. This client 1 is train their own data on their computers, and client 2 as their own data and train on their computers. At the end, the global average model weights of two these clients generated are averaged. Then that is our model weights. If for suppose the uh, client one first value is 1 point this value, and client two value is this, these both values, and global first value is this. Average of these client values are stored in global model weights. We used webhooks for our project. Using a webhook for caching means receiving data for the external service via real-time HTTP post request. and also storing the data locally in cache or database, so that future requesting for the same data can be served quickly without repetition code for the model that nonsense are removed. In our implementation, we utilize the webhooks to handle the image data processing the efficiently. When the user uploads the image, for the following sequence occurs. Image hashing for the uniqueness. Each incoming image is hashed for using the by using SHA-256 or MD5 to generate the unique identifier. This ensures the same image is uploaded again. It quickly recognizes into the reprocessing. Webhook triggering. In real-time HTTP request, webhook is sent to our service with the image data. This initializes the backend process to handle or analyze the image. Caching or caching on hash. Caching based on hash. If the hash of image already exists in our cache or database, we retrieve the previously computed results instantly. This avoids a re, re, recomputation or re-predicting of that model, saving both time and processing resources. Returning the result once processed or fetched from cache, the result is returned to the request and ensuring the minimal latency for repeating the request. If for suppose we firstly uploaded the image, it in terminal it shows like this. In front end also it shows the image is stored in cache. The image value and its predicted value also stores. When the same image is uploaded with the same hash value of this compares they both, if they are same, then the resultant predicted overlaid and also predicted image is returns. This like in output is from terminal, result from cache. The tools we are designed are creating 3D structure visualization. If we give the protein sequence as an input, it gives a 3D visualization of that protein sequence. And also another thing is drug molecular generator. We design this drug molecular generator using a reinforcement learning. If we give the smile as an input, it breaks the IPC50 value and log P value, and also generate up to five smile molecules. Another is smile masking identification. If we give the smile, if we give the smile with the mask as a this like input, it gives the output. What is the other molecules can match with that smile and gives the probability of that molecule. And also ligand identification for the Alzheimer using VIT. If we give the smile as an input, it gives the smile is active or inactive or intermediate. And auto docking. If we give the EC50 number or ligand ID, it predicts the uh, energy scores and auto docking 3D visualization. Another is protein to smile converter. If we give the protein structure and click on convert smiles, it gives the smile and with its generated structure. The another tool is 3D medical image viewer. Basically, in medical field, the input as an image in .ini files. We have to show in that in 3D segmented view. For that, we design this tool. If we give the .ini file, it gives the 3D structure and visualization of that image. Let's see website working flow.